Okay, good morning again. Today's lecture is again the basics, right? Ideally, I should cover all this because we are learning about security, not so much about internet, right? But the question is that how do you understand internet security if uh, you have limited knowledge of internet? Okay, so I thought it will be worthwhile to take few lectures about internet and networking, then we'll move on to real stuff. Okay, and in order to do this, I will need some extra hours. Now, I can teach only if you are interested. Okay, because it requires a lot of effort on my part as well. So let me know if you really need to learn about networking in detail, or you will read of your own, and then we can move on to security for networks, right? Okay. Ideally, this course is taken after you would have done networking course and OS course. Okay, all right. Okay. So let's move on. Huh? Please feel free to ask me questions. There's a lot of animation in today's lecture. If you don't understand anything, please feel free to ask questions, right? Now, this something that we are studying today will also help you in your interviews, right? Because most of the interviews do ask questions on internet or OS. It doesn't matter whether you take degree from data sciences or CS or EE. Ultimately, jobs are in CS, right? Okay, all right. We have just few topics to discuss, more of concepts. If time permits, we'll go into layer one. Okay, all right. So internet is actually a layered model, right? Okay. Now, remember, some of you who have done networking course, OSI is an organization, okay, has defined 7-layer model for networking, right? So because the networks are to be organized according to some functionality. This is physical layer, data link layer, network layer, then transport layer, then session layer, presentation layer. So this is 1, 2, 3, 4, 5, 6, and type is application layer. Okay, OSI has defined this, and when I started studying networking about 30 years back, this model was used, right? And people tried to design using that. And then internet and few other technologies came after that, right? And it was found out that these two layers, presentation layer and session layers, are not really needed. So internet now has become physical layer, link layer, network layer, transport layer, and application. In between two layers, like layer 5 and 6 are gone now. Okay, so it's from 7 layers when we designed internet, or when internet developed, only 5 layers are used. And these are the 5 layers, right? Physical layer, you're actually like wire or wireless. Link layer, whether you're using Ethernet, Sonnet, or whatever. And the network layer is defines basically IP and some other protocols. Then transport layer, TCP, UDP. And then application layer, where applications can work on TCP, UDP. Okay. This application is, there is no standard as such, but any application can sit here. Okay, all right. Okay, so this is the model. Now all these rely upon abstraction. Okay, so basically what we are showing is abstraction of overall functionality of networking, and it's divided in layers because that basically what we are trying to achieve is modularity. Say something that's related to physical medium should be handled by this layer, like transport of bits over a wire. Now wire could be of different type, but then it could be twisted pair cable, or untwisted pair cable, or STP, UTP, it could be fiber, it could be wireless. Okay, it could be anything, right? So now this layer's responsibility is to transmit data over that physical medium. All right. So, but this provides functionality to layer above. Now it means that link layer will use this physical layer to transport bits. It means that there must be some well-defined interfaces between any two layers, right? So we can say link layer uses services of physical layer, network layer uses services of link layer, and so on and so forth, right? Okay, all right. Now, advantage of modularity is that today we are using Ethernet as a link layer. Tomorrow there is a better technology comes in, so we can substitute. So let's assume some XYZ new protocol comes in. So we can put it here, keeping the interfaces same, right? So overall design of network you need not change. New technologies can be put in. All right. So we have seen that internet has 5 layers and each layer has a protocol. The one protocol that's primarily used, but there can be multiple such protocols. Okay, it relies on services provided by low services below it. So this guy provides services to network layer provides services to transport layer provides services to application layer. All right. So, but this is not unique to networking. Not unique. Not only used in networking. Any other example where used this layering model? We use very much in real life, right? Like in OS. OS is also based on layers, right? It's a code, then there is a, this is user mode, the user side, we write a code, then you use runtime library internally use system calls internally use device drivers actually finally gets converted. So all sequences, bit sequences get converted in zeros and ones, and these are sent over a wire, then it becomes voltage levels or radio waves of RF radio frequency waves, right? This is a magnetic radio frequency waves. All right. So this concept of layering exists, right? And advantage, these are easy to design, it's a modular, and then replacement of one functionality by other is very simple. Like device driver can be changed as new devices keep coming in. All right. In real life, for example, Alice wants to send a message to Bob. She says that I am hungry. Shall we go to a restaurant or something like that? And she is in office A and Bob is in some other office. Okay, or maybe different departments in an office, right? Consider this, Alice is in CS department and Bob is in say civil engineering department. Okay, maybe in the same campus, right? She is a senior, so she gives it to mailing department, and then mailing department will put her request in an envelope, and then it says send it to Bob. Okay, now this will so she provides services here to Alice, and then this mailing service within campus, for example, will put this request inside another envelope, and if the Bob happens to be somewhere, that building's name will come here, right? Okay, so this mailing service will send it to say civil engineering department. Civil engineering department, once it comes there, it will go to somebody who is responsible for opening mail, and the person will open the mail and find out is send it to Bob. So this thing will come out. This the one here, not the top one is removed. Once this comes to this guy, and this guy says send it to Bob. Okay, whatever is here send to Bob comes here. So now this guy knows that Bob is working right here, maybe next door or whatever. We'll remove this part and give this letter that I am hungry to Bob. So what we see here, I mean, we do use this method, this layering method in daily lives, right? Okay. For example, your mother sends laddu to you, the courier guy will come and she will give it in a dabba, and then courier guy will put that in a box. The courier guy who comes in a bicycle to pick it up will responsible only from that point to some place, right, where the office is, nearby offices, right, their courier service offices. From there it will go into another dabba depending on whether it's going over air or rail or truck, and so on and so forth, right? So we can see that this model is used everywhere. So now when this, at this point in time, when it goes to mailing service or transport service, then Alice's message is here, that is put into another envelope, send it to Bob. That envelope will go inside another bigger envelope, will say go send it to 123 Bob Street. So once it goes there, all it will remove this part, it will give it to this guy, only these two, send to, and I am hungry, and then it will further go up like this. All right. So basically we have now, what we can say is that at least Bob will never come to know all these things that has happened. Okay. So this is a peer-to-peer protocol. Now Alice knows that Bob understands English. Okay. If Bob happens to be from India and knows only Hindi, right, and Alice knows only English, then this communication cannot happen, right? So Alice and Bob at the same level and must understand language of each other, right? So that the protocol, when two entities communicate with each other in the networking world, both have to understand the language of each other, right? Or state machine of each other. The state machine of both have got to be very much alike, like TCP at both end or UDP at both end, right? Or applications at both end. If you are, both two people are communicating with each other, like we are doing it over uh, you know WebEx meeting, both end have got to have WebEx. Otherwise, one end you try to understand what I'm speaking over Zoom, it will not work. So there's a protocol that we are using is a WebEx protocol, right? Similar. So at each level there is a protocol. Understand? Any question? No? Okay. All right. So now on internet we have also created layers like that where applications are built on reliable or unreliable transport. Now some application may want reliability, some application may not want reliability. So basically we have to at least two kinds of protocols. One will give reliable services, another will give not so reliable services. Say for example, when you are transmitting, application is transmitting a file, a normal text file or word file, then you can't afford to have corruption or error even in a single bit. Okay, so file transfers requires reliable delivery. While when you are watching IPL matches, okay, and then there are large amount of data is happening, large number of frames are being transmitted from one end to another end, then it doesn't matter few bytes are lost. All you will see is that in that event is projected on your screen, then you'll say just maybe 1 or 2 pixels are missing, so it will not make any difference. So when we are talking to each other, if few bytes from my voice is missing, it doesn't matter, right? So not necessarily all applications want reliable services. Check. Okay, so applications are based on reliable and unreliable transport, and these are built over best effort delivery. Okay. Now, best effort delivery, internet does not say that I will guarantee you transmission. Okay, so now if you want to achieve reliable services, then some protocol at this level must do something to get reliability over unreliable network. Okay, and this is built on best effort packet delivery. Now everything, whether a stream of data like in a IPL or whatever, right? When we transmit video, it's just nothing but stream of data that flows from one end to another end. Okay, that stream is nothing, has got to put inside packet, right? So stream is very big, then the stream data will go over multiple packets. So ultimately, whether it's a stream, reliable stream thing or unreliable stream or unreliable application, the application that requires unreliable delivery, everything has got to go over best effort packet delivery map on internet, right? And this is built on physical transfer of bits. So we can see that applications are built over reliable or unreliable services. Reliable and unreliable transport services are based on best effort packet delivery, global packet delivery. Okay, and then best effort global packet delivery, like we have seen end to end, packets will go. Okay, that is based on best effort local delivery like this, and this becomes best effort end to end delivery, and then this based on physical transfer of bits. Is it clear? Any question? So applications are built on reliable or unreliable transport. That is built on best effort global delivery, means that from one end to another end, in between there will be multiple links. So that's based on unreliable or best effort local delivery between different links, between a pair of, two ends of a link. Okay, and that's built on physical transfer of bits. Now, how will you translate this into protocols, right? So we can see applications are here at the top, like email, www, and phone. Reliable and unreliable transport are, this one. Okay, it's here. HTTP, RTP. Okay, so reliable and unreliable delivery. These are the apps. Okay, and these are based on TCP and UDP. TCP provides reliable delivery and UDP provides unreliable delivery. Again, a little shift here. So just a minute. Okay, so applications are these. Okay, these are based on reliable and reliable transport like here. Then these are based on global packet delivery is IP layer. Based on local packet delivery is Ethernet. These two, and actually Ethernet except it'll finally send bits over wire. Is here. Okay, so this is the mapping. So that's the reason IP is something which is common, which is which is the crux. Which, so when internet, so all these things, although part of internet protocol suite, but something that all these ones have got to use is IP, right? IP is if somebody says what is internet, you can simply say the one which uses IP, the correct answer. If you say the one which uses TCP, may not be correct answer. Okay, so on IP TCP can sit or UDP can sit, or and on top of TCP UDP any applications can sit or use. Okay, and similarly below IP will go over local networks like Ethernet or PPP or it could be Sonnet, and this Ethernet, PPP, Sonnets will go over physical medium like copper, fiber, radio, etc. Right? So you can see that something that is common across all combinations of protocols that internet may use is nothing but IP protocol. Okay, so you can see that whether we are, see for example, domain name server uses UDP, will use IP, and that can go over any medium. IP can go over cellular, and say if cellular, then it's radio. Okay, for example, we are using application HTTP, which you use, it will go over TCP, and then TCP internally will packets will go over IP packets will go over, say, Ethernet packets can go over either copper or fiber, and so on. Any question?
No, sir.
Okay, all right. So now we can represent this same thing as follows, right? So now this is host, that's end machine, like your laptop. This host B, this could be a server, say Google server, Amazon server or something. And these are all, this is in between is router. Okay, now you can see some difference, right? The protocol suites at the end will contain these two layers, transport layer and application layer, in addition to these three layers, physical, data link and network. While routers contain only three, physical, data link and network. Because reason is that only at the end you as a user will demand you want reliable service or unreliable service. But applications are always run at the endpoint. You are not running an application over router and interacting with that. Okay, in most of the cases, right? I mean, you might want to set up some router and something that at that point in time there will be communication between two, but forget about that. In general, routers use only three layers. Okay, so now responsibility of reliable delivery or unreliable delivery or security, etc., is responsibility of endpoints here. Okay, all right, you got it? Okay, all right. So lower three layers are there everywhere, whether it's end host or router and so on, all throughout the network. Suppose your data is, you are here, this is your machine is going through, say, so many routers, right? 1, 2, 3, 4, 5. So everywhere in each of these router, these three layers will be there, because responsibility of this layer is to transmit data from, for example, here to here. So the protocol that's running a network layer must find out what is the path to be followed, and then based on that it will transmit packet on appropriate port and over the local area method, right? For example, if this copper using ethernet using copper, then it will use some protocol. If this is Wi-Fi or wireless, it will use different protocol. If it is Sonnet, then this link is uses Sonnet, then different protocol will be used. If this uses, say, for example, satellite, then different protocols will be used. So ultimately a packet that's leaving your place will travel here, the first node. From there is a copper, so appropriate data link layer will be used. Then once it reaches here, and then the router uses wireless, then Wi-Fi, then a different protocol will be used. If you use Sonnet, then different data link protocol will be used, and so on. Okay, any question? No?
Sir, like initially we pass the things through switch,
Mm-hmm.
but switch is layer 2 device. So how does the network part gets transferred?
So, so look at this. We'll of course come there, but it's a very good question, right? We don't ever pass it on to switch. What are you running? You are running an application. Okay, application is sending the data. It has got to go, and when you are sending it, you are at the endpoint. Okay, it could be in same machine, although, right? Okay, so you are running then you have to, whatever your application, say for example, right now we are using WebEx, right? So WebEx is using internally some voice over IP app. Okay, it's a MGCP, MAGAC, or SIP or whatever, and that will use internally TCP or maybe UDP, depending on how application design. So these two layers are will always be there. This example here, HTTP, for example, will use TCP. Okay, and then IP, and then Ethernet. So your packet, whatever you are doing, will come here, and from here it will go to the router. Or okay, now router can understand only this IP layer, right? But here it will use Ethernet, right? So basically, router sits over a switch. Okay. All right. So we will come to, when we come to layer 2, then we'll look at how Ethernet works, how switches work. Okay. Now Ethernet internally, see, finally you are going to get Ethernet packet. Okay. Now Ethernet packet is to be switched across within a LAN, right? Okay, right now we are not talking about local area network. We are just assuming that there is a router connected to your machine and so on. But this thing could be a LAN itself, right? So we'll discuss that case later. Right now, just understand that what we are discussing is that the different layers and how the packets are getting encapsulated with each other, and we'll see concept of local area networks and how Ethernet packets are switched, and then how it is routed. So we'll look at the difference between the two little later, once you understand what Ethernet is. Okay, is it fine?
Yes, sir.
Right now, let's look at, try to understand what is being discussed, and just park your question, and when we study LAN, we'll discuss this. So now we'll see that this packet that comes from top get encapsulated inside lower layer packet. Okay, so TCP packet is here. Now TCP packet gets what? Data of TCP packet is corresponding to HTTP request. Okay, now this is a TCP packet. Now when TCP packet comes to IP, then it gets encapsulated within IP packet, and so on. When this further goes down, because you can't send IP directly over wire, you need layer 2 or Ethernet, right? Like when your mother sends a box containing laddus, she will not just throw it on the road assuming it will reach. It has got to be given to courier guy, and that courier guy, they are coming on bicycle with a box that will, in that box she will put the laddu box, is actually Ethernet, and responsibility of that courier guy is only up to the end of the road where the office is. That's it. Over there, that your mother's dabba will be taken out and sent it over truck to different city. Now that road from that point to other point, if you treat as a single road or link, right, then that becomes another protocol, layer 2 protocol. Okay, and so on and so forth, right? Okay, so we'll look at that point later. So now this IP packet will go inside Ethernet frame. All right, so we'll look at this. Same thing here. Let's assume that you are you are watching a movie from Netflix, right? So all the communication here is happening over packets. Okay, now this guy is sending a stream of data. Ultimately, this server, it has, all this data corresponding to a movie are in some video frames. Okay, and these frames are nothing but a stream of data, right? So this stream of data has got to come, but we know that stream can come over packets, right? Okay, so first thing that you do is that you send a packet, that multiple packets to Netflix, that I want to see something, right? And Netflix server responds back by a sequence of packets. Remember that, right? So all the communication on IP happens over packet. Now this diagram, this simulation is done essentially to point out. Although now when you do this, get the data from Netflix, it appears that you are directly connected to Netflix, but it happens over internet, which is nothing but a large number of routers. And these routers know how to transmit your packet. Okay. So now actually you can see, okay, all right. So while same thing that we are depicting here, this is your program and this is somebody else's program, and you got a sequence of data. Right? Now actually it happens over internet like this. Okay. So your packets go to the other end. Okay, now here it is very simplistic view wherein all the packets are taking same path. And similarly, when this guy responds, the packets will flow in the other direction. Maybe a different path, not necessarily same path. Okay, all right. Now this is another view that now, for example, my machine is connected to router over internet, but packets still my machine is generating data packets. Okay, and same thing, my voice is getting converted into bits and bytes that will go over TCP. Okay, TCP will sit over IP. This whole packet will come here over IP. This is IP. It's going over Wi-Fi. So this header of Wi-Fi, this whole thing is coming here. Okay, and this will go to this point, and this point will remove this part and deliver it this portion and so on, right? So now my packet goes over here in this way, right? So ultimately it's just packet. Now these are very simplistic view because some of you have no understanding of networking, so it will understand. So if I have to send a picture of Mona Lisa, so it is nothing but it can be treated as a sequence of bytes. Okay, starting from bottom or so on and so forth, right? Okay, and then and it may be a file, but in a file is nothing but a plain any file will also have header, and look at the structure of a file. It has some metadata. This is about actually how this data here is structured and how it's to be used. Okay, anyway, so now we can split this into sequence of bytes, and then we can send this. So let's assume these three portions will come here in a packet, and this packet will go to the other end, and the other end will collect the data and application logic. If you use the same application logic, like PDF or whatever, we'll reassemble it and present it, right? So all this can go. So these three are taken, and TCP write, for example, address to address, IP address. TCP will come inside and you will write IP address, sender's address, and then it will go to the other end and will reassemble back. Okay, same thing. So whole picture can go in sequence of packets over IP to other end. And of course, this what we have shown is IP packet, but IP packet will sit over Ethernet packet and so on and so forth, right? So now we have assumed that everything reaches to other end, but internet does not provide reliable delivery. It says the best effort, I will do whatever I can. That's what internet says, right? So the packets on the way can get damaged. Okay, unless some bits may get flipped or some bits may be lost. Internet does not give any guarantee of that kind, right? Now, second thing may happen is that packets may reach out of order. Ideally, first packet should reach first and second packet should reach second. Even a file, if you change the order of bits, then file is lost, right? File is corrupted. So, but internet, it may happen that second packet may reach first. Okay. And thirdly, packets can get duplicated. So if packet is duplicated and duplicate packet reaches to end, so one has to be discarded, right? So there has got to be enough, and protocol must take care of all this. Okay, or packet may not arrive at all, it may get dropped. Okay, so now AND protocol must, if you want reliable delivery, then AND protocol must also take care of this. All right, now the question is how packets find their way in internet. So we have seen that the global routing that happens uses IP address. It does not use, TCP does not have address of its own. Okay, TCP simply says that what port is being used and which application is using it. Okay, it has a concept of port number. Now, IP address corresponds to a machine. It corresponds to this machine. Okay, for example, and this machine may be running multiple apps. It may running HTTP, it may be running, Microsoft Word, it may be running something else, right? So app 1, app 2, app 3, right? So once packet reaches here, then one has to return which application it has to be delivered to. Okay, that comes from TCP, that says that, or UDP, it says that it goes on a particular port number. Okay, so let's not worry about that at this point in time. So what we say is that aim is that a packet, IP packet is given at this place, this is the header, it will have IP address. All the nodes will look at this IP address and do the global delivery, right? So we have seen that each router has two functions, local delivery, local function, and global function. When you say global function, this IP address is enough structure for this node to know which link it is to be sent to, which path it is to be sent to. That path is available because these routers exchange messages to each other. Okay, this is called routing algorithm. We will not discuss this, right? So by this, the node knows where to send it to. So IP packet comes here, it will look at this global IP address, but that's very unique. Now it has a knowledge, like is a policeman has a knowledge because he has spoken to other policemen that somebody from Mandi goes to say Delhi, where to send it to. Now if it has a multiple routes, multiple outgoing link, then this guy will decide that if something is with this IP address come, it will be sent here or here and so on, right? So that's kind of internal action, right? But at each point in time, once this packet reaches here, second router, it will again look at the IP address and decide which link to send it to. It decides to send it to this link and so on. Okay, all right. So, okay, so now it will look something like this. This IP packet is here. It will have IP address. Now we are not talking about Ethernet frame at this point because on this link, it will go over Ethernet, for example, or layer 2. And this point when it receives, it will remove this and only packet will be IP packet. Okay. When, for example, if suppose it sends the packet over this link, then again this IP packet will put into Ethernet and then so the IP packet will come here and then Ethernet header will be here. It's received here, it will remove this Ethernet part and look at IP, take the decision where to send, and then again put into another Ethernet frame and send it to this one, right? So that's the normal method. Okay, all right. So based on IP address, decision is taken where to send it to. So however, layer 2 functionality is only up to receiving end of the link, right? So for example, your mother's box of laddu, when it reaches, the courier guy will put inside another envelope, another box, and say the local address of the courier office on that road, right? When this guy removed, but this guy has, once it received, has no use of the outer dabba. Okay, he will remove outer dabba, looks at your address, okay, or IP address, and then decide where to send it to. Okay, if it's for example, dabba is being sent to Mandi, then guy in Delhi will decide where to send it to. They'll put in another dabba and send it up to appropriate link. Okay, so that's the normal method. So So IP address is this is 32-bit IP address. It will look something like this, 180.23 or 143.2.2. Of course, these are all hex. All right. So your packet, IP packet, will travel in this way, for example, because the routing algorithm will say that use this path at each node. All right. Okay. Now local action will say that when something comes here, then which link to send it to. All right. So now the packets will go like this. Okay. Now this IP address has a structure. Okay, this is a built-in knowledge, you can say. Okay, looking at the IP address, for example, if you look at my IP address, you can find out this IP address belongs to Bangalore. Okay, if I look at the IP address of, for example, Silicon Valley, it will have some part which will tell me that it is belongs to US and that in particular Silicon Valley and so on, right? Okay, so based on that, and some when you study, for example, OSP or BGP, will understand how these router exchange information with each other and fill in a routing table in each node, right? So each node will have a routing table, and we'll say that if IP address, part of the IP address something, then what is going to be the next link, and so on and so forth, right? Okay, all right. So applications send and receive packets. At top level, we see only our packets are being sent, and which is sent over internet, which is unreliable. Okay, and packets forwarded hop by hop to final. So packet go in this hop, then this hop, then this hop, and this hop. Okay, so this is a network by itself. This may be another network. This may be third network, right? This could be Ethernet. This could be Wi-Fi, Ethernet cable. This could be fiber. So each will have different layer 2 protocol whose responsibility is to send the packet across the link. Okay, that's the reason we call it link layer. So a path end-to-end routing is done based on IP address, but link layer's responsibility is send the packets across the link. That's it. As simple as that, right? So internet cannot be trusted because it does not promise delivery of packet in order. It does not promise even packets to reach quickly or on time, or it does not even promise delivery at all. Packet, as we have seen 3 cases, packet may be lost, it may be duplicated, it may reach out of order, or it may take huge time. It may, because of, if each node has a buffer, then it will take a lot of time, right? So it just uses best effort delivery. So what internet does is, what we do is sending data reliable. Then question is, how to send data reliably over internet that is unreliable? Many applications like file transfer, others want reliable delivery. So we want to achieve reliable delivery over unreliable internet. Then end applications have to take care of it, right? If the packet is lost, just number the packets, for example. If the and you receive acknowledgement. If you don't receive acknowledgements from destination, then you resend the packet. All these tricks are used. Okay, a network consists of many things like host, routers, links, and links of various types, applications, protocols, and so on, right? All right. Okay. So this is the one which you have studied. Okay. Now what happens is that this, IP just provides a pipe. As we have seen water pipe, right? Okay, but when we are sending data over it, for example, stream of byte, then it has got to be structured in some way, right? So that if you want stream data that too reliably, then we have to use some protocols on top of that. Okay, so now what we can say is that we are going to byte For example, one model is a byte stream model, which we use in TCP. Okay, some application, you write an application, it assumes I have a stream of zeros and ones. It will create a stream of zeros and other end I want application to receive a stream of zeros and ones. It doesn't bother about some boundaries, it doesn't bother a packet and so on. Then we are going to use TCP. Okay, then in order to do that, it will set up a connection. Set up a connection is nothing but having an understanding between node A and node B about a lot of parameters. Okay, now it will say, now hello, I am going to start communication now. Okay, all right, some other parameters exchange we will study later, right? So once connection is set up, your stream of data, I will go back again, stream of data can be sent by A to B. Now your application is generating these streams, but this will go over TCP, will structure it slightly and then it will go over IP. Okay, but your application view is nothing but stream of data. And then once this communication is over, close it. Now, apparently to you, it will look something like this. The application writer will look only at these things. But internally, it will happen differently, right? Okay. Opening a connection, closing connection, transmission of data, and so on, right? Okay. So set up a connection like HTTP. Set up a connection is the first thing. It means the understanding between this and this guy. Okay, and then communication of data is a stream of bytes like get, HTTP, whatever, and then it responds back. This is again a stream of data, and then finally closing the connection. Okay, but actually your data is going, IP is just put data into it's a payload, right? But you still need some structure. Okay, if something is lost, if you put directly data into IP, something is lost, you cannot recover it because there's no concept of numbering, etc. Right? So what happens is that your data in a packet will go, but we are going to use TCP here, right? So TCP makes sure that all data is delivered, okay, correctly. So we can, for that we can have sequence number. First thing is stream of bits and bytes are converted into packet some size, okay, and which will go into IP, and then these are numbered. It says first packet, second packet, third packet, and so on. Receiver will receive that and put them in order, okay, and if something, and send the acknowledgement. So destination will send acknowledgement. If it doesn't reach, then sender will resend it. So that's all TCP is, right? Okay, but the concept here is that TCP packet goes into IP, IP packets go over Ethernet, Ethernet from one node to another node it will go. So for example here, again go to Ethernet, that outer frame will be removed and IP packet will be transferred. Then IP envelope will be removed, it will go to TCP and TCP will send it to app. So there is the structure. Okay, now let's look at it again. So it's like this. This is HTTP request, stream of bytes corresponding that will fit into TCP payload. So we'll put here TCP header. We will look later what TCP header is. It will have surely a port numbers because it has to decide which application. HTTP will have corresponding port number. Okay, and then this will go over IP, right? So it will say now this HTTP request will go to TCP. It will say deliver to HTTP server at the other end, right? Okay. Now at this level, TCP is in action, right? Between this server and this this node and the server. Now this TCP packet will go inside an IP packet. So now there is an IP packet. Now at this point in time, you will say that just go to a node where the server is, right? And okay, so this IP address will say that you go at some place. Okay, that's it. When okay, all right. And now note that this IP address is global, so it means that this packet has got to go to a global address, but internally there are multiple routes, nodes are there in the route. Okay, and this could be Ethernet, this could be say Sonnet, this could be satellite. So it means that it will, this packet, for example, when it goes from here to the next router, will put into Ethernet, right? Because this link is Ethernet link. Okay, so it's like this. All right, you got it? Any question? Any question? Okay, all right. So what happens when this packet goes to next router on the road? So now this corresponds to only a link. Starting at this link, this Ethernet link, so at this point is starting, it will be received at this point, second router, and it will now based on this Ethernet frame, it cannot take a decision because it doesn't know what is inside. So it will throw away this part and move only this packet to a higher level protocol, and then it will know that this is IP address. So now send it to in a particular link and use that address here, destination Ethernet address, and so on. Okay, all right. So this packet which is created is meaning only up to this point. Okay, now after that the Ethernet packet is removed. Okay, so what you will get is the one shown here. Okay, and then when it is sent over this one based on IP address, then it will put into other Ethernet packet if this is also is Ethernet. Okay, and at this point in time, when it reaches here, the internal packet is taken out, IP address is read, and then it will put into, it decides that it will go over this link, it will put into another frame corresponding to this link. In this way, hop by hop, it reaches to destination. All right, so it works this way. All right, okay. Okay, so Alice goes to a cafe. We have discussed this. We want to discuss this at the end anyway. So another 5 minutes and then we'll close. Alice goes to a coffee shop. She boots her machine, so it's a fresh, and she looks for a wireless network, Wi-Fi networks. Similarly, Wi-Fi access point says that, look, I am here. Okay, and then of course this is not a secure medium. Air on air, anybody can read, so they will do a key exchanges, right? So now they can establish a secure session. Okay, now what protocols we are going to use for that? Obviously, we'll use asymmetric key encryption for exchanging of keys, and then symmetric key encryption, right? All right, just think about it, right? So now she needs, once this is set up, then she needs what? She said, I need IP address. I don't have IP address. IP address is assigned locally, right? We have shortage of IP address. And then she will also need, now she wants to do google.com. Now google.com is not an IP address. She needs then domain name server address. And now she is inside a local area network, and she needs that what is my gateway address, right? For example, in campus, some motorcycle guy will say, I have to go to somewhere. Then you'll say, okay, go to a particular gate. Similarly, in any net, like in this cafeteria net, there is one gateway address. Okay, so she wants all these three, right? So she says, her laptop says, hey, anybody on this local area network, give me basic configuration. Okay, normally DHCP, there's a protocol called DHCP is used. DHCP is usually available in the same net. So now if let's assume DHCP is there, this server is there, it will send her configuration like IP address, gateway system, gateway address, and then domain name servers. Note that this is happening at Ethernet level. She is not using IP communication as yet, right? Because she has got IP communication now. So on a local area network, you use only Ethernet. And how we'll use this, that we'll study later. Okay, now she has got all these three. Now she wants to know what is the address of google.com, because IP uses IP addresses, right? So she uses UDP, and then she sends it to DNS, domain name servers, which she has got as a part of the configuration. So through gateway she sends this, and then finally it goes to DNS server, and then she gets the IP address of google.com. Okay, all right. Now she sets up the TCP connection using SYN. We'll study what SYN is later. And this is the Google server, right? And this Google server will respond back. Okay, SYN ACK, etc., etc. And then now she wants to do reliable communication, secure communication. So uses HTTPS. Okay. Now, in order to do HTTPS, this guy will say, this is my public key. Okay. Now, Alice, how does Alice trust this? And this guy may also send a certificate of that. Have you studied certificates, right? So now she will, what she can do is that she will accept that and send a test. She will send a blob. Okay. And then this guy will decrypt it and send the answer back, and then she will know that is actually google.com server. Okay. Okay, so she will send blob one some data, uh, and blob is nothing but randomly generated data, and she will just say that I'm encrypting this, your public key, you decrypt it and send the answer back, and if that's done, then it's all done. So she established TLS channel using HTTP, and now she can do the query. That's it. That's the answer, right? All right. So that's all for today. Any question? Yeah. No question?